Today I'm going to be talking about reactions of alcohols. Now, to define what an alcohol is a compound with an OH connected to an alkyl carbon. Now, an example of an alcohol is CH3CH2OH, and this is ethyl alcohol. Now, in this video, I'm going to be explaining a couple reactions of alcohols. The first reaction an alcohol undergoes is a dehydration reaction. Now, a dehydration reaction is when an alcohol is formed with a strong acid catalyst to form an alkene. In a dehydration reaction, an OH is lost from one carbon and an H is lost from another carbon to form an alkene. An example of this is in a dehydration reaction, an alcohol loses an OH and an H from the adjacent carbon. So what you end up with is two carbons double bonded together, which is an alkene. Now, not all dehydration reactions form only one alkene. And in a reaction forming two alkenes, there is a major product and a minor product. Now, to determine which alkene is the major product and which one is the minor product, you have to look at which carbon has the least amount of hydrogens connected to it. Now, I'm going to show you an example of when an alcohol is reduced into two different alkenes. Now, to determine which one is the major product, you must look at which carbon adjacent to the carbon connected to the OH has the fewest amount of hydrogens, because the double bond forms better with the adjacent carbon with the fewest amount of hydrogens. So in this case, the fewest amount of hydrogens is a CH2. That means that for the major product, the alcohol yields butene. As you can see, the CH connected to the OH and the CH adjacent to it lost an H and formed a double bond. Now, the second product is the minor product. And the minor product, so as you can see, the one on the left is the major product, and the minor product is the one on the right because it has 3 carbons versus 2. Now, the minor product would look like this. Which becomes 1-butene. And that is a dehydration of an alcohol. Now let's take a look at an oxidation reaction of an alcohol. To start off, let's draw an alcohol. In an oxidation reaction, 2 hydrogen atoms are removed from the alcohol. One from the OH group and the other from an H connected to the carbon group, as seen here. Next, an oxidizing agent is used to form a carbonyl compound. An oxidizing agent is represented by the O in 2 brackets. Now, an oxidizing agent can be many different things. 2 examples are potassium permanganate or potassium dichromate. As seen here. Now, different types of carbonyl compounds are formed based on the structure of the alcohol and the reaction conditions. There are three types of alcohols: primary, secondary, and tertiary. Now let's take a look at what each of those form when they are being oxidized. Primary alcohols have one R group. And when oxidized, they form an aldehyde. And when an excess amount of an oxidizing agent is brought into the reaction, it forms a carboxylic acid. So let's take a look at that. When a primary alcohol is oxidized, it yields an aldehyde. And this is a basic form of an aldehyde. Now taking that aldehyde and oxidizing it further forms a carboxylic acid. As seen here. Now that is an oxidation reaction of a primary alcohol. Now let's take a look at a secondary. A secondary alcohol is an alcohol with two R groups. Now when a secondary alcohol is oxidized, it forms a ketone. As seen here. That is a reaction of a secondary alcohol. Now, taking a look at tertiary alcohols, things get a little different. Tertiary alcohols do not react with an oxidizing agent because they don't have hydrogen on the carbon with the OH group. Because tertiary alcohols look like this. They have three R groups, so therefore they have no hydrogen to react with the oxidizing agent. Next, we're going to look at some real-life applications of reactions of alcohols.